This section we're going to talk about physical and chemical changes and physical and chemical properties. So a physical change is one in which the state or the appearance of the substance is changed, but what it actually is, those smallest particles, atoms, or molecules, are not changed. An example can be seen in this picture. You put some water on the stove and cause it to boil. So it was a liquid, and as it boils, it turns into a gas. If we were able to zoom in and see what was going on at the molecular level, we would see that the molecules in the liquid state and the molecules in the gas state are exactly the same. They have just changed their distance to each other and how much they're interacting with each other, but it's still little water molecules. So the atoms or molecules of a substance do not change their identity during a physical change. A lot of these changes are going to be state changes, going from a liquid to a gas or a solid to a liquid. Those are going to be physical changes. A chemical change does involve the particles changing. The composition of the material changes. An example here is an iron nail rusting. So here's what the iron atoms in the nail would look like. They're individual iron atoms, and they're arranged in a particular structure. When the iron reacts with oxygen, the oxygen becomes combined with the iron atoms and forms what we call rust. I think we all, from experience know that rust is a different color and has many different properties than the original iron. So you could build, a bridge out of iron and it'd be really nice and strong, but you wouldn't build a bridge out of rust, right? Because it's flaky and it doesn't hold together. The substance itself has changed. It's undergone a chemical change. So this is an example of chemical change. Here's an illustration of a physical change. This is dry ice subliming. So solid carbon dioxide is called dry ice. So here we have the carbon dioxide molecules, and they're all snugged up real close together. Dry ice is dry, unlike regular ice, because it doesn't melt. Regular ice melts, and if you've got it in your cooler, then your sandwiches get all soggy, right? Even though they're in supposedly a waterproof bag, right? The water always gets in there. When dry ice warms up, it goes directly into the gas state, and that is known as subliming, going directly from the solid to the gas state. There aren't a lot of things that do that we might encounter, but dry ice is one of them. So when this happens, going from a solid to a gas, the molecules themselves are not changed. The physical state of the substance has changed, but the molecules haven't. So this is also a physical change. This is a physical change that is less obvious, sugar dissolving. So here's an illustration of sugar molecules in your regular old table sugar. And so they're bigger and more complicated than carbon dioxide. But we see these molecules. You take a teaspoon of sugar, you stir it into a glass of water, and it dissolves, right? It kind of disappears. If you stop and think about it, that's pretty cool. If you put sand in there, does that do it? No, you can stir it up and it just sinks at the bottom. But you put the sugar in there and you stir it up and it's like, it went away. Well, it didn't. It dissolved. So what happens is we still have these same sugar molecules, but now they've separated from each other and they're mixing in with the water. So the particles have not changed. It's still sugar. It's just its physical appearance has changed. So this is a physical change. Something dissolving is generally a physical change. Here's an illustration of a chemical change. Propane gas burning. Propane molecules look like this. And here's a little camp stove. It's the same stuff in your gas barbecue outside. When the propane combines with oxygen, it changes into carbon dioxide and water. So the original propane molecules are nowhere to be seen over here. They came apart, There were no red ones, red balls over here, because those are the oxygen atoms. So they've combined with oxygen, made completely different things. The original substance is destroyed. This is a chemical change. The composition has changed. Anytime you see the word burning or combustion, almost always a chemical change. So we can also have chemical and physical properties, and they are quite closely related to those changes. So physical property is one that the substance displays or that you can observe without changing the composition of the substance. An example would be the smell of gasoline. So gasoline has a distinctive smell. The process of me smelling the gasoline does not change the gasoline, right? Now, if I light the gasoline on fire and burn it, that is also a property of gasoline. It's flammable. But demonstrating that property or displaying that property causes the gasoline to be destroyed. Physical property does not involve changing the substance. So the odor of something, its taste, its color, its appearance, melting point, boiling point, density, all of those can be displayed or observed without changing the substance. Chemical properties are only displayed by changing the composition, and these are really just descriptions of a chemical reaction. So gasoline is flammable. It reacts with oxygen, burns to form carbon dioxide and water, mostly. Other examples of chemical properties: corrosiveness, acidity, and toxicity. So let's just practice that a little bit. For each of these statements, determine whether the change is physical or chemical, and identify what kind of what kind of property is demonstrated. So what we want to do is think about, okay, the substance involved. When this process happens, is the substance changing or is it staying the same? The individual molecules or atoms. So a copper wire is hammered flat. It's going to be a physical change. We're changing the appearance of the wire. It's not round and skinny anymore. It's going to get flat. But the copper atoms aren't changed. They're just getting deformed and spread out in a different way. So we can state this as a property of copper, that copper can be hammered into a sheet. And so that would be a physical property of copper. How about a nickel, like the coin, dissolving in acid to form a blue-green solution? That is chemical. This one's a little tricky because the word dissolves a lot of times is just describing a physical change, like salt dissolving in water. That's a physical change. But here the nickel is dissolving in acid to form. So this tells us something new is being created, right? The color is changing. That's often an indicator that we have a chemical change. So this is a chemical change. And this is a description of a chemical property of nickel. It will dissolve in acid to form a blue-green solution. Dry ice sublimes without melting. Physical. We just looked at a picture of that, right? All that's happening is it's changing its physical state. The molecules are the same. A match ignites when struck on a flint. Chemical. Once you strike that match, it's done, right? It's not the same anymore. You can't just say, oh, let's do that again and strike it again and have it ignite. It does it the one time. It undergoes a chemical reaction. The original substances are destroyed, and you can't just repeat that over again. So that is a chemical change. Any questions? Here's looking at some pictures. So this diagram represents liquid water molecules in a pan. I don't know why it needs to be in a pan, but whatever. So then we're going to look at panels A, B, and C and try to identify which of those best represents the water molecules after they've been vaporized, put into the gas state by boiling. So I heard A and C. Both of those are good thoughts. This is where the molecules have come apart into their individual atoms, which is not actually something that happens when it's boiling. That would require a chemical reaction. Boiling is a physical change, and so the individual molecules are going to look the same. And so A is the one that's going to be the physical change of vaporization. Any questions?